Okay. Oh, there goes the alarm telling me it's time to start the stream. So maybe you can let me know in the comments if you can hear me okay, if the volume's loud enough. Hello, Sam, Apple Eden, Phil's Arcade, Rohan, Advan. Hi, Sylvan. Hi. Hi, Jimmy. Cool, okay. So yeah, this is the... I guess I've done a bit of streaming before, normally with bring up stuff. But I've been inspired by BitLooney. If you're not familiar with BitLooney, then check him out on YouTube. Hi, Andy. Good to see you here. Hi, Mike. Oron. And he has two channels. He's got like a streaming channel and his main video channel. And I really like the way he's able to take his kind of live streaming stuff and then cut that into his videos. And he's got a really nice community going on over there, like we do here as well. So I thought I'd just give this a go. So it's an experiment. Totally open for suggestions for things to cover, ways to improve it. So feel free to make any kind of comments. And I'm going to start off by just showing a little bit of news. So one thing I want to start off with is some of the Tiny Tapeout 6 results we've got coming in. Let me open this up. Share my screen. So we've been working with Texplained. So if you ever need chips reverse engineering or professionally decapped and imaging, they're good people to go to. And they've done this, taking apart our Tiny Tapeout 6 chips, etching them out of the packaging, and then doing some imaging. And this is a deep zoom in of Uri's design. We can take a look at that later. I think we've got the overview is here. So that's what the chip looks like with the power distribution network. But he's done a great job of scraping just top Metal 5 off. So then you can see from this view all the designs underneath. And that is great news for people into silicon art, because it means the kind of stuff you do on Metal 4, you're going to be able to see that. So we're seeing more people submit silicon art, and I managed to get my first silicon art on Tiny Tapeout 7, so I'm looking forward to seeing that soon. So yeah, that's great. And we've also seen lots of people getting their chips back from Tiny Tapeout 6. So let's take a look at some of those, what people are saying. Maybe I'm just going to share this whole window. So it's great when people tag Tiny Tapeout or hashtag Tiny Tapeout. So for example, this is from Ignacio, and he did a cool triple redundancy project on his chip, and I liked his little write-up here, and how he was bragged to the clerk at the post office that he was picking up a chip he designed, and the clerk was like, I don't care, I couldn't care less. Totally resonate with that. What else have we got? Good news from Meinhardt. Meinhardt did a scalable RISC-V core Phasey RV, really interesting RISC-V project, and got that up and running, doing some demos and animations. And then we've got Carsten Wolf, who I interviewed about analog for the channel, and he taped out a really interesting SAR ADC, which he's just got started working. He's just looking at getting his characterization set up working at the moment, so he hasn't like measured any interesting signals, but it's great to see that one working. And another one from Saroj Rout. Their first tiny tape-out board doing a communication with a digital temperature sensor, and that's all working nicely. So congratulations to everyone. Keep the results coming in. It's really fantastic to see these things happening. And for people who submitted, and even if you didn't submit, we're going to be organizing a bring-up party soon. So the idea there is get everybody together on a stream like this and take it in turns to show off our working designs. Okay, so some other bits of news. I just want to draw attention to Efabless. Got ChipChat number 4 happening. Live Q&A for the chip curious. January the 21st at 9 a.m. Pacific time, which is 6 p.m. Central European time, and that's Tuesday. Always a good webinar if you've got questions about Efabless or the ChipIgnite program. And for those of you who don't know, ChipIgnite is the service that we use to tape out all tiny tape-out chips on. And Efabless very kindly sponsor our project. It wouldn't be possible without them. So big thanks to Efabless, and definitely well worth signing up and checking out one of their webinars. Anton normally hosts them, at least part of them, and he's a really good host. So you should go and say hi to Anton. Actually, I wouldn't be surprised if Anton was in the chat. If he's not, then he can watch the replay. Okay, what else have we got? Okay, so we also have it's about once every 6 weeks, the Yosis users group, the YUG. So we just had YUG 9. Actually, I need to update this website here. And that was a presentation by Christine about how the synth ICE40 flow works. So if you use Yosis, is in use all the way down with the open source ASIC flow. We use it for synthesis, we use it for equivalence checking, we use it for formal verification. And for people that also test their designs on FPGAs, which is definitely recommended, you're going to be using the synth ICE40 flow most likely. And Christine did a great presentation on how that works. And if you want to check out that, you can check out the video recording that we did there. All right, so a couple bit more news. Tiny Tape-Out 10 is open. We always have a shuttle running. As soon as we close one, we've got the next one. So Tiny Tape-Out 10 closes in 50 days. Got plenty of space left at the moment. 63 cheap boards left. It's really incredible. If you want to get a cheap tape-outs for just $150, it's just absolutely amazing. We've got the price down that low. Thanks again to Efabless for sponsoring that. There's 63 of those left. Afterwards, the price goes up to $300. And yeah, we've got some projects already in here, including this analog one. What's this one? Oscillating Bones, another one from Uri. We'll probably take a bit of a look at that later. Okay, so IHP, with Efabless, we're on Sky 130. But we've also started collaborating with IHP, which is the German fab that I did my semiconductor tour on. And that was a great experience going to see where the chips getting made, but I didn't get to see any of my chips getting made. That's still on the bucket list. But we may be able to do that with IHP because we're now starting to work with IHP. We've done 2 experimental shuttles with them. The first one, we just put all the designs into one big blob and merged it together. And then for IHP Tiny Tape-Out 2, we've got a code name, but I can't actually remember what it is. Is it on our chips page? Yeah, TT-IHP 0.2. So that ported our normal kind of MUX with these different designs. These are all contributed from the community. So these are in manufacture at the moment, but we just got news from IHP that the dies are ready for our first 0.1 shuttle. And we're going to have a public shuttle in mid-2025, in probably 4 or 5 months' time. A little bit more news. Stuart visited Shenzhen recently and got this great chip on boards done recently, which is really fantastic. So that normally chip on boards are covered with a black epoxy and you can't see the chip, but we had these done with a transparent epoxy, like the LED is like a W7 WS2812 LED. And I can actually get this working. If I just plug this in, you can see the LED starts flashing. So this is from a chip that we did with the 0 to ASIC course. And it is one of the ones that still includes the Caravelle RISC-V processor, and that's just running a little program flashing that LED. So it's cool to see that working, the power and all those other wires connected up. So thanks to Tamash for doing that breakout design, and Stuart for taking it over to Shenzhen and getting it built up. I interviewed Stuart about his process there. So if you want to check out these videos, check out that interview video if you're interested in knowing more about that. And yeah, then I'll just shout out the store. So you can buy previous Tiny tape out boards, development kits in the store. And we've got a VGA clock kit. It's one of my first designs in support of the Open Source Hardware Association. We've donated $500 to them already. You can get our sticker packs. You can buy hats. You can buy that chip on board. It's kind of non-functional unless you have a Tiny Tape Out 1, 2, or 3 board, which would then provide power. And I could probably send you the firmware to run it, but it's kind of more meant as a memento rather than something that you would run. And then there's also souvenirs from my previous runs, like my very first ever chip mounted in epoxy resin, and you can order them all from the shop as well as the awesome hats. And big thanks to our CMO, Chief Merch Officer, Stuart Charles, for getting all the merch in the shop sorted out. All right, so that's the news part of this stream done. And we'll move on now to what I want to mostly cover. Let's have a look at the comments. Oh, got hello from 1 a.m. in Korea. Wow, Mark, thanks for tuning in. And we've got some questions. And yeah, Sam, you're right. Best place if you've got questions is probably the Tiny Tape Out Discord. Just take a look at the channels we have there before posting a question, see if you can get it in the right place. And that's always appreciated. So yeah, the question for the Discord link. Let me... Sylvan says, does the RISC-V crash if you shine UV light at it? I haven't tried that yet. I've tried flashing it with a torch, but I think I need a bit more energy to crash it. Let me see if I can get a banner up with the tinytapeout.com Discord. So if you want to get involved with the community, then this is the short link for the Discord community invite. And that's a great place to get started and get involved. Yep, and I guess it's also good to just call out, join the mailing list on 0toasiccourse.com, subscribe to this YouTube channel. If you want to get more involved, do a tape out with Tiny Tape Out. If you want to get even more involved, then do one of my courses. We've got a digital course and an analog course. Yeah. Hi, DAP Cuba. Target demographic. You're in the target demographic. We work with high school students. Really, the demographic is anyone who hasn't had who's like curious and who hasn't had access to silicon before, which turns out to be quite a lot of people. Previously, the tools were extremely expensive to rent, and then even if you made a design or you used the open source tools, which have come a long way in the last 4 or 5 years. But now we have the ability to do tape outs for like $150. Like I said, if you get early enough. Yep. So moving on then. I wanted to start with looking at Alex's simulation. So I can put this up here. So probably some of you have seen this before. We had it on the, I think it was maybe the GDS Art channel and in the Discord. And I interviewed Alex today. So that's going to be edited and probably posted this week or next week. And this is a rendering of his design. So let's see if we can find it on the Tiny Tapeout website. Cellular. Was it Tiny Tapeout 9? I'm sure I've got a link to it. Yeah, TT09. Let's just go straight to this page. Oh, yeah, here we go. There's the tile. So this is his design. This is the GitHub repo. So everything that we do is open source. So you can check out his code here. And this is a rendering of the design, and probably on the repo the actions will be up to date, so we should be able to look at the 3D viewer as well. Yep. And one thing in particular, this design has got a lot of flip-flops in it. If we have a look at, let's see, this one, that's a buffer. That's a flop there. DFXDP. There we go. I can hide all the flops. You can see how many there are. And they store the state for this cellular automata. The main page is this one. I'll just drop that in the comments so you can have a look. And what he did was he wrote some Python software that would extract the netlist from the GDS. At the time, he didn't actually know about LVS. This is something I found out today, layout versus schematic. So Magic is the tool that is used to extract the netlist that is then used for LVS, but he wrote his own tool. And then he's simulating his design as it runs. So when the cells go white, that means they're going high. So you see this kind of floating around through the design on the left-hand side. That's all those flip-flops that we just saw. And over here on the right-hand side, we've got like the counter for the VGA output, because when you plug this design in to VGA, it's going to do one of these classic cellular automata videos. That didn't work. Full screen. You can see it down here at the bottom. And every now and then it changes the rules of the cellular automata. And this, you can see it building up at the top here in cyan, what is coming out on the VGA. And we can slow down this so that we can see things ticking as the clock goes. And we can speed it up to top speed and we get to see it flowing out. It's still going to be quite a fair amount slower than it's going to run on your actual VGA screen, but it's so cool to see this happening. And I interviewed him today about what he's going to be, how he did this. And one of the questions was, can we adapt this to work with other designs? And the answer is, yeah, he's already got quite a long way along to do that. And in fact, he did it on Ray's drop demo. So for people that don't know, we had a demo scene competition where you basically had two tiles of Tiny Tapeout and you have to use the VGA and the sound P mods. And we've got these categories, we've got some judges, some prizes, and we had 30 entrants including this one by Ray and a bunch of other people, I think. I think Alex said he updated. Ray, Eric, Matthias, and Alexander were all involved in this project. And he didn't need to, I think the only thing he needed to do was point his code to the new GDS and change it so that it did this using more tiles, because this is a 2-tile design. And if we speed this up, we can see the VGA output slowly getting built up until we get the drop text. That's the name of this particular animation. And one thing that Alex noticed was that you've got stuff happening on the left here, and then you've got stuff happening on the right. So he was thinking all the video stuff is happening over here on the right. I mean, the demo scene involved audio stuff as well. So after it's raced the beam, because there's no frame buffer in these things, that's the moment when it starts computing the audio, and then you see that happening over here. That's just Alex's theory. We don't know. Ray, maybe you can tell us. Check it out sometime. So that's great news, because hopefully that's going to mean that we'll be able to take our design, so like that 3D viewer that I showed you earlier, and as well as that, we'll be able to have one of these simulators. So you'll be able to simulate your design and see it happening with all these cells lighting up, which I think is really fantastic. Looking forward to seeing that working. Alex said if anyone is interested in helping him do that and integrating it into our build system on the GitHub Actions, to let him know. So if that sounds interesting, then get in touch with Alex on the Discord. Let's just load up the Discord. So I think probably, was it in GDS Art? Yeah. So Alex is Alexander Mordvintsev on the Discord. If you love what he's doing, just give him some hearts on his recent post there. And if you want to get involved, then maybe just say that you want to get involved down in this channel. And we'll see if we can move that on. That'll be great. Okay, let's see if we've got any comments. Hey, Ray, thanks for joining. Ray and Andy talking. Andy also did an amazing demo scene competition entry. I'm hopefully going to be showing some more of those soon. Hi, Devin. Thanks for joining. And Jürgen. All right. What have we got next? So, yeah. So if you're interested to know more about that, then subscribe to this channel and you won't miss the interview when I post it later this week. All right. So next thing I want to show off is this amazing. I think we had 13 RISC-V cores at least taped out on Tiny Tapeout over 2024. I was doing stats. The search on the website is all right. If you type in RISC-V, it's pretty good at finding RISC-V stuff. And this one is capable of booting microLinux SoC. It's one of the biggest designs we've ever had on. It's on Tiny Tapeout 6. It's one of these enormous ones at the bottom there. It's with Tiny Tapeout, we're limited to 16 tiles. It's the maximum size. So Hirosh needed all of them. This design also needs a little memory blob. That's another thing that we're limited on Tiny Tapeout, is memory is very expensive in terms of area. So Rebel Mike, and I think Leo might have been involved as well on this PMod that adds flash and SRAM for designs that need lots more RAM. Just get rid of that banner. And so this one makes use of that PMod. I think on the version on Tiny Tapeout 5, it needed, like, the pinout was slightly different, and on Tiny Tapeout 6, it's using this standardized one. And yeah, big thanks to the people in the community for helping us with that. So we've got the Tiny VGA, the audio, and the QSP IP mod have all been contributed by people in the community. I think it's awesome P-mods for the list of all the community P-mods. So if you're doing a project that needs an extension, it's worth checking one of these because maybe somebody's already done it. And then the most popular ones, we manufacture them and sell them in our store, and you can put them on as a cheap add-on when you make an order so that you can try people's designs. So like on Tiny Tapeout 8, we've got these 30 demo scene projects. So if you get the VGA P-mod, you'll be able to try all of them out yourself. So anyway, back to Linux. Uri wrote a doc on getting Linux to boot. Makes it extremely easy. So he did made a system where you could easily flash your P-mod. So if I plug this in, connect to the board, and then I can click this flash button, and it's going to flash this P-mod through the RP2040. You can see it's picked up the idea of the flash, which I won't actually do that because I did that. I got that set up before the stream. So now I can just follow the rest of the instructions, which is go to Commander. And this is another thing that is fantastic about Tiny Tapeout and all the infrastructure is just how easy it is to get going. So the first project that's taped out, where is it? The chip ROM consists of the shuttle name and the git commit hash, like embedded into the silicon. So when you plug in the commander, it's able to read what the chip is, and then it can then find a list of all the projects. So I can search for RISC-V here or Linux to get that project. Right, so now I can enable that project, and it needs a clock speed of 30 megahertz. Just thinking how long we've come since Tiny Tapeout 1, 2, and 3 that were just like the serial scan chain working at like 1 kilohertz or something. Now we're running Linux at 30 megahertz. Okay, so then now I need to reset it. And then in the REPL, I have to copy and paste this. Control-Shift-V, and then Control-D, and then press the reset button. Yes! Ray and Devin geeking out, and Andy about demo scene stuff and music. Yeah, Jason, the Nandland is a great project. Nandland's got a good YouTube channel. And then there's also the NAND to Tetris course, which is another good course if you're interested in looking at how this low-level stuff works. So I think we get one of these dots every 30 seconds or so. And I think after 5 or 6 dots, it's going to start booting. Here we go, starting the kernel. So what? Send me some comments. What commands should I run in Linux? And I'll copy them and paste them into this Linux, and we can see what happens. MicroPython. I don't think MicroPython is on this, but Rebel Mike has also done a RISC-V microcontroller SoC, and I'm pretty sure, in fact, that might have been one of the ones I managed to forget. Yeah, let's showcase Rebel Mike's post here. And look at that. Thanks, Mike. Nice little promo shot there. So this is what you get in the Tiny Tapeout 6 dev kit. And he posted this thread on getting things working. So I was able to compile and get some stuff running. And Bruno's Donut GPIOs are working. And I think I remember Mike saying he got MicroPython working. Maybe let us know, Mike, if you're watching this or later on. Pretty sure I remember that was working. Rohan, we can build our own Linux image. So if you're interested, you can go. Uri's also got these like as a stretch goal if you want to compile the system image. So then you could potentially install whatever you wanted to see on there. I don't know enough about it to know if RISC-V. Mike's saying there is a MicroPython for KeyNV, but I don't know if there's binaries there. Okay, so let's check. Do we have it booted? Yes, we have a console. Okay, so people are telling me to format. So let's see what happens with uname A. Linux 6.8 up to date. Come on, DF. Cool, as you can see, it's pretty slow. Yeah, let's just, do we have Cowsay? Oh, no such file or directory, sorry. Top. I don't think we've got top either. That's one of the ones I tried. One thing that Hirosh did tell me, there's an executable in, oh, there we go. Cool, we got top. Sweet. Let's see what we've got in root. Oops, what have I got? What have I done now? Oh, I've pressed Control C. I've gotten out of the console. Dang. Let's see if I can recover. Control Shift V. Control D. Okay, yeah, great. My problem is I don't know how to quit top now without also quitting the without quitting the REPL. How do you do that? If I run top here, Q works for me on my Linux. Why doesn't it work here? Type busybox. Yeah, Q's not working. Okay, so that's probably enough now. There's a nice little renderer on there as well that I could show, but I won't do that this time. We can instead move on. I don't think Control D is going to work. That's going to get me out of my REPL. Oh well, we'll finish this one here and say congratulations, Hirosh for KeyNV and Uri for making that so easy for testing. And Tatzel Brum is criticizing us for being digital weenies. We are arguing with a root shell, but it is on custom silicon running Linux, so that's pretty good. is millions of transistors instead of 5s or 10s. But I do have on my list for later, maybe we'll check out some analog designs on Tiny Tapeout 7. So we added like official analog support on Tiny Tapeout 6. And so we've got Tiny Tapeout 6 and 7 back. Now I just got my Tiny Tapeout 7 board. So yeah, let's move on with that then. So here's my Tiny Tapeout 7 just arrived. Thanks to Stuart and Sam and the rest of the team for getting that together. Got the obligatory rainbow wrapping paper. And let's see what you get in the package. Thank you. There you go. You can scan that QR code and go to Tiny Tapeout 7. Nice infographic with how everything works from Pat, Psychogenic. Thanks, Pat, for the PCB design and the documentation. And then in the boards, we've got the new colors. This is the new color scheme for Tiny Tapeout 7. Thanks, Efabless, again, for the sponsorship. Quickly checked. 97%. And some stickers. All right, so let's see what happens when we add this we'll go to the commander. Plug in the board. Tiny Tapeout 7, 2.0.3. Got the factory test, and that is running, so that's great news. And some easy projects we could check would be some VGA projects. So let's search here for VGA. Let's go with this screensaver. Set the clock. Reset it. Okay. I can see some faint lights happening on the 7 segment, which is like a relatively good sign for VGA stuff. So I do have a VGA. I've got my clock running here on a Tiny Tapeout 5 dev board. So I will sacrifice that screen and we'll see what happens when I plug this in. Oh, we've got a sync. We've got a Tiny Tapeout logo bouncing. Excellent. Good job, Uri. Do we have we've got the pin out. Interact. Where's the repo? And the documentation. Oh, we've got color output, UI in 1. Let's see what happens if we try that. Oh, yeah. Changes color when it bounces. Nice. Okay. Definitely report results. Tested with black and white and color output on the TT VGA PMod. Yeah, that's something else I can show you quickly. We've got the just going to do this on a different screen actually. Highlights. So we've got this kind of prototypes at the moment, and this is just at the moment it's not really highlight. The idea is we're going to start tagging some projects that we particularly like, and they're going to show up here. But for now, we're just linking to all the designs that have been silicon proven. So every time someone submits a project and says that it works, we're going to list it here. So I don't know if that gets updated straight away. Look at that. Yeah, and there's my feedback. Sweet. So for all the people out there with tiny tape-out boards, remember to submit results on your design, and even better, if you can test other people's designs, that's really good. We really have very little information about things like yield. So far, everyone's designs work, like it either works for everybody or it doesn't work for everybody, but we don't really have great numbers on that. So the more people that test designs, the better. And the more people test your design, the higher up you can go in the project highlights. So I think it's great to see this. This has always been one of the really difficult problems with the open source silicon stuff, is like getting to the end of that long journey. You know, you've got to hear about the project, you've got to be motivated, you've got to do a design, you've got to submit the design, you've got to wait 7 or 8 months, you've got to then get the thing and take it out of the box and plug it in and test it. And the number of people that get all the way to the end is pretty low. And so we super appreciate everybody that fills in that form and lets us know how it went. Okay, so let's try another one. Let me just check the comments. Noriegatube is saying, take his design, 8-bit counter. Maybe tell me what number that is. Okay. 8-bit counter. Is this on Tiny Tape-Out 6? Because I've already moved on to Tiny Tape-Out 7, I'm afraid. Oh, maybe this one. Counts up. Maybe set this to 1 hertz. It's definitely doing something. Just hold this up. I don't know if that is what you're expecting, or if you can even see it. Maybe a bit closer will highlight the LED. Maybe if I had the LEDs wired the correct way, it would be doing what you expect, but it's looking pretty good. And then back to 0. Yeah. Looks like an 8-bit counter to me. Congratulations. Let's try, I'll do a, I'll submit results here. At 1 hertz shows LEDs going on and off like an 8-bit counter on the 7seg. Not sure if it's correct yet. Maybe you can check when you get your board. So let's go back and find another VGA project. VGA checkers. Oops, something's happening. I was expecting it to be like a game of checkers, but it's looks like one of the demos from the VGA Playground. But I think I meant to mention that before. But on the VGA Playground, this is a really good way of these checkers. Here we go. Yeah, it looks the same. So maybe Ronaldo just taped this whole design out. But this is a lovely way of getting started if you're into graphics, because you can just play with this stuff live in the browser here. Let me try and change something. Not making the biggest differences. Checker shape. Oh, there we go. So it's like a very nice, fast, interactive way of playing around with stuff. We've got some other things here for you to play with, and then you've just got this Verilog that you can copy and paste into the into a tiny tape out repo and tape it out if you want to. So let me go back here and report results. Shows what looks like the default checkers pattern from VGA Playground. .com. Okay, that's nice. Couple VGA Snake. Yeah, it works. Hurrah! VGA Snake. All right, we've had one more. Snake. The screen's gone red. Let's see if there's any instructions. Left, right, up, down, UI in 0 to 3. I don't see any snake though. Maybe it's a partially working. I might come back to that. I won't submit a report yet. Ah, that's the game over red screen, right? Okay, snake is sleeping. Lol. Oh, Barak, is that your game? Okay, well, we're planning to be shipping. Oh yeah, this is an announcement. If you're on Tiny Tapeout 7, make sure you give us your address. You can update that through the app, and you can let Stuart know on the Discord. And I'm going to be sending an email soon. And we've got them made before Chinese New Year, so we should be able to ship them out pretty soon. You should be able to get them soon if you're on Tiny Tapeout 7. All right. Actually, there was one other VGA one I wanted to try, which was Anton's Raybox Zero TT07 edition. I'm not sure. Did you test this one, Sylvan? Oh, look, we've got something. This one's in portrait mode. I think I read something about being able to set these pins to be able to If you don't have the SPI controller, which I don't have set up, then I can set ink pix and ink py. So that's 4 and 5. Oh, look, it's doing something. Okay, it's moving my point of view in the maze. So that's looking pretty good. I don't see any textures on the walls. Was there like a built-in texture? Can't remember. Oh, got some stats down there now. It's looking pretty good though. Ah, there we go. Wicked. So pretty good news for Anton. And that was a design that has been taped out before, but we saw some problems with it due to a toolchain issue. That was then we saw that it was broken on the screen, and then when Anton did the gate level netlist test, he saw that there was a problem. Looks cool, man. All right, so let's see if we've got any more comments. There we go. Yeah, I've got any things. Okay, got it. All right. So last 10 minutes, let's try a little bit of analog on Tiny Tapeout 7. So probably I'm going to... We've got quite a few analog projects here. I got my Moss band gap. Well, actually, there was one that I wanted to try, which was the oscillating bones. Do we have that on here? Dixon charge bump. Or maybe that actually, no, that was on Tiny Tapeout 6. Yeah, we don't have that on here. Okay, let's try. Actually, we can try my VGA clock quickly, see if that still works. 903, select, set. Great. The classic is back. And then we'll try the 20 sine wave generator, I think. So this is one of my analog designs. Op amp plus a notch filter equals sine wave out. It looks like I've already tested actually, but let's try it again. Yeah, we can see if it's repeatable. Start it up with no scope attached. Okay, so, and I'm gonna want to move this over to the scope as well. And what's it doing as well? It looks like it's is it doing a counter here as well? Ah, 20-bit digital counter connected to the oscillator. Top 8 bits are connected to the LED. So if it's working, I should see it counting. Oh, yeah. Should have probably shown that over here so you could have seen it more easily, but I've got the scope connected. So let me present that window. Yeah, Sylvan, I was thinking the same thing, but because it's got those 10K pull downs, but I can see the oscillate, I can see the counter running. So I think it is running, but maybe it's going to change how the waveform looks. Now with the analog projects, because of the way the analog mux works, and if you're interested to know about that kind of stuff, then you can check out videos on my YouTube channel with Sylvan, who did a lot of the mux work, along with Harold Prettel. And so you need to know where that pin goes. So my output pin is routed to B5 on the PCB, so that's where I've got a probe. Okay, so that's not bad. Pretty good. That's measuring 5 megahertz. So it's a different chip than the one I tried last time. And that might be because the loading is different. Can I FFT that? Yeah, I should be able to. I don't have the little pigtails attached, so I can't run it while I'm at the screen. So that's why I'm stopping it after I've taken enough samples. But clipping. Yeah, okay. Well, this is maybe something we can look at another time, just coming up to the top of the hour here, and I want to wrap it up now. So we can have a look at this next time. We can continue this next time. The other thing I want to try is on Tiny Tapeout 7, we also have a 555 timer. Was it 7 or was it 6? 5. Oh, it's on 6. So I'd like to have a look at the. I'd like to try and get that that 555 timer clone working. So that's an idea. Also, feel free to leave in the comments or get in touch on the Discord or DM me or whatever ideas of stuff you want to look at next time. I'm also thinking I'm going to do a bit of RTL work and update my VGA clock. So just to close up, thanks for joining. Next week, same time, same place. And just a reminder to subscribe to the channel and to the mailing list, and have a great week, and hopefully see you all next week. Thanks for joining.